When we write our numbers out, we're going to want to write them in a very neat way, the neatest way possible. One way to write out numbers, especially if they're really, really big, or if we want to compare them with other numbers that might be big or small, is to use scientific notation. So to write something in scientific notation, I have 6 steps here. The first thing to do is to determine the number of significant figures, and then write those significant figures out. No commas, no decimals. Then we're going to place the decimal after the first digit. We're going to write times 10 after those numbers. We're going to count how many spots the decimal would have needed to move to go from where it was in the original problem to where I placed it in my new set that I've written. And I'm going to use that number as the exponent on my 10. If I move the decimal to the left, I'm going to use a positive exponent. If I moved it to the right, it's negative. If you've never seen this before, that sounds like a bunch of gibberish, I'm sure, so let's do some examples. So here's my first example. I'm going to write out my significant figures. 1, 0, and 5. Now, the decimal was here, and I moved it to that spot in between. Oh, I didn't write it down yet. All right, the second step was to put my decimal in. So there we go. So what I need to know is I know how many times do I need to move the decimal from this spot to here. 1, 2, 3, 4, 5, 6, 7. So I'm going to write times 10 to the 7, and I need to figure out whether that 7 is positive or negative. If I move to the right, if I move to the left, it's positive, and that's what I did here. Another way to think about this is if it's a big number, right? This is in the millions, or if it's in the billions. If it's a big number, keep it positive. Here's our second one here. Our second number is small. It's a little number. So what I'm going to do is I'm going to take these numbers, my significant ones, and I'm going to write them out. I'm going to put a decimal after the first number, and I'm going to write times 10. Then I'm going to say how many times do I have to move to get from this decimal to where I've placed it here. 1, 2, 3, 4 places. And this time I move to the right. It's a -4. Another way to think about this is when I have a small number that I'm writing, put a negative sign there instead of a positive sign. Lastly, if I have my number -2.4, I'm going to write 2.4. I keep the negative there. I put my decimal after the first one, times 10, and then I figure out how many times I have to move to go from where the decimal place is here to where the decimal place is here. Well, 0 times. So that's how you would write -2.4 in scientific notation. I can do this backwards as well. I can start with something in scientific notation. I can go the other way. One way to do it is plug it into your calculator. If you plug it into your calculator, you'll get the answer, but there's no need to do that. Once you get the hang of it, this isn't too bad. You can almost do it in your head. So what I'm going to do is I'm going to write out my significant figures. And I'm going to look over here and I'm going to say, all right, so to get a +2, I had to move this decimal 2 places to the left. While I'm undoing that, I need to move this decimal 2 places to the right. And then I'm going to place it there. And that's all you got to do to undo scientific notation. We'll do it one more time. I'm going to write out my numbers, 2, 4, 2. This is here. If I have a -4, that means I moved it to the right. Now I have to move it to the left to undo that. 3, 4. That means I have to put 3 zeros in here as placeholders. Don't forget the negative sign. All right, so the last thing about scientific notation that I want to mention is that it can show relationships quickly and easily. So we'll write these out really quickly in scientific notation. I have 1.3 meters would be written as 1.3 times 10 to the 0. 12 meters would be written as 1.2 times 10 to the 1. 100 meters would be 1 times 10 to the 2. And 1,240 would be 1.24 times 10 to the 3. So if I have everything in this picture here, what I'm really looking at here is my exponents. And every single time that my exponent gets bigger, let me erase that, I wrote over it. Every single time my exponent changes, that means that something's changed by 10 times. If it goes from 0 to 1, that means, I'll use a different color. If I go from 0 to 1, that means it's 10 times bigger. If I go from 1 to 2, that's 10 times bigger. If I go from 2 to 3, that's 10 times bigger. So if I go from 0 to 3, well, that's 10 times 10 times 10. That's 1,000 times difference. So I can judge the size of things a little bit easier using scientific notation. I could also go backwards as well and say that going from here to here is the same thing as reducing it by 1/10. Let's say that I had a list of planets away from the sun. You could see how much further something is away just by looking at this exponent, by knowing comparatively how those numbers relate, rather than looking at these big numbers that seem kind of arbitrary when you just see lists of numbers with lots and lots of zeros in them.